All right, welcome, Tolk. I think I was gonna say, but anyway, welcome back. Aside from that language slip up I had there, we're gonna be doing another video in Python, Cosmic Python, which is also called Architecture Patterns with Python. That's the name of the book on Kindle, but they're offering it for free on this site, cosmicpython.com. So I've got a bookmark set up here from where I left off last time. And that is the introduction. Why do our designs go wrong? Before I read that, I would like to show some things I did in between videos. So this is from the last video, but in the last video we learned about 3 recommended ways of following along with the code examples in the book. One is just answering the questions that they'll give you at the end of each chapter. Another is using their code examples and trying to get them to work on your own equipment. And then the third way of following along with this book is when it comes to coding, is to design your own project and try to put the principles of this book into use for that project. And use the examples and the book questions as kind of an aid to help you accomplish that. So that's what we're going to be doing when we go through this book. The project is going to be automatic turn-ups of networks depending on the design, depending on the equipment in the network. Basically just organizing all of your business requirements for the network and then having code that makes it so that all you need to do is provide some code for your smart hands, the boots on the ground, to install on your gear, and then have the Ubuntu server where your code is running just automatically take care of the rest and set up your whole network basically whenever you want. Basically, instead of having to coordinate real time with your boots on the ground, your boots on the ground at their convenience, the business requirements convenience, just go whenever they want. They apply a few lines of config, they plug it in, and then you don't even have to be there. Just as long as your Ubuntu server is up, it's just going to automatically configure the network. So we're going to be doing something like that. Now the initial design I'm going to go with, and we could go with all sorts of different kinds of network designs, but we're just going to stick to a basic campus LAN and wireless LAN solution design. So we'll be using this as a way to find out what we want to configure on there. So I just placed some gear in my topology to make this LAN hierarchical design in my lab. So we've got Juniper VMX's big devices for the core. Then we've got some Aruba OS CX's for the distribution. These only have 9 ports on them. And then we've got these Open vSwitch devices with 15 ports at the edge. So as we're going through the design guide and stuff, we might switch this up as we learn like what a better device would be for these requirements. But for now, this is what I got. So we can start up everything. Yeah, and then the first step we're going to need to do is set up a management network on all of these. What I'd like to do is have everything on a special management VLAN, not the default. And then I'd like to have QoS set up so that the management traffic can't saturate the links beyond like 5 or 10%, but have the highest priority so that if there is an issue and the links are saturated, the management traffic can get in there. So I'm going to take a note here. So we're going to say, and this will be called a base config. So we'll say base config requirements, and we'll say, but I like to call it kind of a smart hands, because this is, I like to call it a smart hands config, because this is or even better, I think, would be an out of band config. This is the config that you have to apply out of band. In band management, you don't have the ability to apply this. So we want to, in band management VLAN, we'll need to pick one for that. Then we want management VLAN QoS. Then we want management link management traffic saturation restrictions, and then we want management highest priority for we want the highest priority for management let me see here, management highest priority for management traffic. The other thing we want is a and this is going to be the most challenging part. I'm not even sure how to do this for a lot of them, but we want some sort of persistent connection mechanism that will make it. So we'll say persistent connection. Yeah, so what I mean by that is we want something to happen to where if the device can't access the jump host anymore, it'll roll back its last configuration because it will assume that it's lost its out in band. So we want some sort of recovery technique. So recovery mechanism. So that's another requirement for our out of band config, if that's possible to set up somehow. And then let's see here. I got one more, and that's let's get NTP. Well, you know what? So we want to save as much as possible for the automatic config, because one reason I wanted to call this a smart hands config is because you're going to be handing it off to somebody, and look at how many devices, 1, 2, 3, 4. So they might have hundreds of devices they've got to put this config on. So you want to keep it as concise and small and free of variables as you possibly can. So the other thing we're going to need is an IP address or like ZTP. So let's put ZTP slash DHCP. Yeah, because we don't want to have a smart hands person say, okay, this is the Aruba spine 1, therefore it gets this address. We just want them to plug it in and be able to, we just want them to say, okay, this gets IP DHCP, or even better yet, ZTP enter on all of them. Best thing is that if they're already all set up, but unfortunately they will need to do something. But if the easier you can make it on them, the smoother it's going to go. Because never mind the technical side, they've just got to carry all the switches and do wire everything up. It becomes quite a handful, even when you don't have a complicated config. So if you throw a complicated base config on top of that, it just gets more and more likely to go awry and cause delays. So yeah, I think this is all we need for now. Yeah, we're going to have a QoS policy on there. And this is another thing that we could have in our final config requirements. But let's call this initial. And then let's make another one called final config requirements. Okay, and then let's take as many things out of the initial config requirements as possible and put them into the final config requirements. So we are going to still need the in-band management VLAN. Another thing is no shut ports and allow management VLAN. That's got to be in there. But we don't need the management VLAN QoS in the initial config requirements. We could put that in the final config requirements. So let's move that there so that it's one less thing for the boots on the ground to have to worry about getting correct, and one less thing that can go wrong. We're also going to need, so this is another thing too. These are both parts of that. Okay, so the other thing we can put on later is the persistent connection or recovery mechanism. All right, so now we've got kind of the initial things we're going to think about for the network, kind of aside from network design, just kind of the practical implementation elements. In our initial config requirements, we're going to need, of course, a in-band management VLAN that our server can communicate on, and we can have so there's a number of ways to do that, but we're gonna, I think, just do a single failure domain, single broadcast domain throughout this whole topology for that, because all we want to do is make it as easy as possible for the boots on the ground to just plug it in and go. So setting up multiple VLANs, setting up IP subnets is something we're going to do automated. So the other requirement is we're not going to give each of these a IP. We're gonna have them set up by DHCP, and then we're gonna have a DHCP pool on the Ubuntu server. An alternative to that could be ZTP, which is a special mechanism some of these devices have. It's basically similar to DHCP from what I understand. Okay, and then the final requirement would be no shutting the ports and making sure that the management VLAN is allowed across them. So these are all going to need to be trunk ports. Oops, I'm actually missing one more requirement. We have to make sure that some version of spanning tree is enabled. Otherwise, for these sorts of connections here, we'll just have a broadcast storm. So we've got to have some kind of spanning tree so that we're not causing broadcast storms while we're trying to set up our final design, which actually might not require, because once we put these into aggregated links, and they're operating as one link, we won't need STP because it's a different topology. It's a just a straight line connection, point-to-point connection. But until then, we've got a ring topology which requires STP, or else it'll just keep looping. Okay, so I think that's all we need though. So let's go back to the book and keep reading. We'll keep this design zone up. Oh, actually, one more thing I want to do before I keep reading. So these are the 4 tabs I'm going to need. I would like to do a poll on this. So I've got my Ubuntu server. This is going to be where I'm doing most of my work from. So this is a virtual machine on GNS running on my Dell PowerEdge R610 that I got from Save My Server. Oops, and I don't know what the password is, but I think it'll tell me if I go configure, usage. Okay, well that's what I did. I don't know why. Maybe oh, okay, it just took a while. Sweet. Okay, so next we're gonna open a terminal. I'm pretty sure I can do a Control T or Control Shift T, Alt T. I thought there was a way to. Apparently not. Okay, but let's just use the GUI. So we're gonna go on here. We're gonna click Ethernet 3. First of all, let's see where this is wired in. So this is actually wired into Ethernet 0, I think. Yeah, Ethernet 1. So let's take a look at. Okay. Okay, so that looks. Okay. First of all, I just need a terminal. I need a terminal. Please give me a terminal. It's really laggy. Oh my god, this is really laggy. Okay, I've got my terminal now. I'm not sure why this is so laggy. We don't want to upgrade it. The most important thing is the version of Python though, so if we can't get the proper version of Python, we will need to upgrade. But for now, I've got my terminal, so let's see if I've got internet access. I do, perfect. So everything is good to go. Let's do a sudo apt get update. And we're not logged in under the root account now, we're logged in under a user account named GNS3, so we'll need to use the sudo command so we can get those root privileges by entering in the root password. Oh my god, this is going to take forever. This is a disaster. This is an absolute disaster. Okay, well, while I'm waiting for that, let's make some progress in reading the book. Introduction. Why do our designs go wrong? What comes to mind when you hear the word chaos? Perhaps you think of a noisy stock exchange or your kitchen in the morning, everything confused and jumbled. When you think of the word order, perhaps you think of an empty room, serene and calm. For scientists, though, chaos is characterized by homogeneity, sameness, and order by complexity, difference. That's interesting. That's kind of the opposite of what you would think. For example, a well-tended garden is a highly ordered system. Gardeners define boundaries with paths and fences, and they mark out flower beds or vegetable patches. Over time, the garden evolves, growing richer and thicker, but without deliberate effort. The garden will run wild. Weeds and grasses will choke out other plants, covering over the paths until eventually every part looks the same again, wild and unmanaged. That's interesting. It's an interesting way to think of it. And it makes sense, like if you take a snapshot of a messy area, like things look generally the same in that snapshot. But if it's nice and ordered, you take a snapshot and you see one thing, you go over, take a snapshot, and you see you're organized, something or another. Things are a lot. You can basically take pictures that look a lot different in an organized area, but in an unorganized area, basically all you're going to see is a messy apartment. But if it would organize, you would see a bookshelf, you would see maybe a kitchen, dining room, you would see different easily identifiable things. Software systems, too, tend toward chaos. When we first start building a new system, we have grand ideas that our code will be clean and well ordered, but over time we find that it gathers cruft and edge cases and ends up a confusing morass of manager classes and util modules. We find that our sensibly layered architecture has collapsed into itself like an over-soggy trifle. What's a trifle? I know what a truffle is. Oh, it's a cake? I guess that's... Is that a cake? That looks like a cake. It looks different than a cake, though.
Trifle.
It is pronounced trifle. I don't know, that doesn't look good to me. It looks like kind of like Jell-O. Like, I'm not a big Jell-O person. Oh no, it is a cake. But it's like it's got a lot of like jelly and like it's like more like a Jell-O cake. I don't know, that doesn't look good to me. Software systems are characterized by a sameness of function. API handlers that have domain knowledge and send email and perform logging. Business logic classes that perform no calculations but do perform I/O. And everything coupled to everything else so that changing any part of the system becomes fraught with danger. This is so common that software engineers have their own term for chaos. The big ball of mud anti-pattern. A real-life dependency diagram, source enterprise dependency, big ball of yarn, by Alex Papadimoulis. So this is a real-life dependency diagram. Any section of it, so you can see this here is really dependent on these other things. So if those other things go down, this here is really screwed. But this here, it looks like it's not so dependent on everything else. So I guess I would think that a better diagram would be either things that are more equally dependent on other things, or things that are not all that dependent on other things. Hopefully we'll see. Tip. A big ball of mud is the natural state of software in the same way that wilderness is the natural state of your garden. It takes energy and direction to prevent the collapse. Fortunately, the techniques to avoid creating a big ball of mud aren't that complex. Encapsulation and abstractions. Encapsulation and abstraction are tools that we all instinctively reach for as programmers, even if we don't all use these exact words. Allow us to dwell on them for a moment, since they are a recurring background theme of this book. The term encapsulation covers two closely related ideas, simplifying behavior and hiding data. In this discussion, we're using the first sense. We encapsulate behavior by identifying a task that needs to be done in our code and giving that task to a well-defined object or function. We call that object or function an abstraction. Thank you. I've always wondered what an abstraction really was. And now I know that an abstraction is a well-defined object or function. Take a look at the following two snippets of Python code. So we're using URL lib. We're going into this DuckDuckGo API, and we're looking for images of sausages, it looks like. So I don't see any safe search enabled. I know on some, like Pixabay and stuff, you can enable a safe search. But I'll try it anyway. I'll do this on the other screen. And then I'll share it if it is shareable. Oh, okay. Here we go. So it's just text. So Yeah, so it's just a definition for what a sausage is. A sausage is a cylindrical meat product, usually made from ground beef, often pork, beef, or veal. Yeah, I mean, you can just, that's cool. You can just grab in sources like that using this URL lib API. Oh, it looks like we got another one here. We can do basically the same thing, but we're using the requests module. So let's run that again. So I'm just running it in Python interactive shell here. Oh, and it looks like I got the result. Oh, it's because I don't have, so let's do my project. Let's do env scripts activate, and now let's do the same thing, and I should have requests now. There we go. So now we can do the same thing, but we're using this library called requests. Both code listings do the same thing. They submit form encoded values to a URL in order to use a search engine API, but the second is simpler to read and understand because it operates at a higher level of abstraction. So we know what an abstraction is now. So encapsulation and abstraction are tools that we all instinctively reach for as programmers, even if we don't all use these exact words. Allow us to dwell on them for a moment, since they are a recurring background theme of the book. The term encapsulation covers two closely related ideas, simplifying behavior and hiding data. In this discussion, we're using the first sense, which is simplifying behavior. They're not talking about hiding data. We encapsulate behavior by identifying a task that needs to be done in our code and giving that task to a well-defined object or function. We call that object or function an abstraction. So this is, I'm kind of confused here because, oh, you know what? It's an object. They're giving it over to an object. So the object they're giving it, I think is going to be this parsed object. Let's take a look at what kind of data type that is. Okay, so it's a dictionary. And this is a list. And that's a dictionary as well. So I don't see an object or a function in here. So I guess I'm confused what they mean by that, because I really don't see an object or a function. So it looks like the second one uses a higher level of abstraction. I guess I don't know what they mean by that because I don't see an object or a function. So, I mean, I guess everything is an object in Python. So just because there's nothing that says that it's an object doesn't mean that nothing in here is an object. In fact, it means the opposite. Everything's an object in Python. So this here, when I do a type on params, it's a dictionary object. So okay, so that makes sense. So let's take a look at the objects in this code. So everything in Python is an object. So we have a library object. Let's see if we've got that in here. Nope. So we don't need that in this second one. Okay, now let's look at this URL. So let's paste this first example in. Okay, and then we'll take a look at the objects here. So code works perfectly. So we've got the JSON objects. We'll do a help on that. So this is a oh, actually, let's do a type on that, not a help. Okay, so we've got a module object. Let's take a look at the URL open object. We've got a function object. function object. Take a look at params. Dictionary object, handle. Now we've got so we've got a HTTP response. So this is an HTTP.client object that was given to us as part of the URL lib. So we can see already that's a pretty complicated object we're working with. And if we do a raw text, we've got a string object, and finally if we do a parsed, we've got a dictionary object. So you can see already we've got 1, 2, 3, 4, 5, 6, 7 objects we're working with here before we even get down to the result. But here, this new code, we've got the same objects. We have a library object, but we're going to be using the request library object instead of the JSON. Then we don't even need these two objects because our library objects, request library objects, takes care of it for us. We need the params object like we do here. We need the parsed objects like we did up there. And then we need the results objects down here as well. So for this piece of code here, you do the same thing, but you do it with 2 fewer objects. Actually, never mind, you do it with 4 fewer objects because you don't need those functions pulled in from those libraries. So, I mean, that's a good deal. The same exact thing, but with 4 fewer objects. I mean, that sounds good. Both code listings do the same thing. They submit form-encoded values to a URL in order to use a search engine API, but the second is simpler to read and understand because it operates at a higher level of abstraction. It has 4 fewer objects. We can take this one step further still by identifying and naming the task we want the code to perform for us and using it as an even higher level abstraction to make it explicit. Okay, so now instead of these params objects, we can just import a library called duck.py and use that, and then we can do duck.py.query and iterate through this object here, giving us an R object. So this is the highest abstracted way of doing this because now you don't need these params here. They're automatically taken care of for you by the abstraction you receive through this duck.py library. Okay, so let's give that a shot. And I don't have that library. I will prove it by trying to import it. So, no module named duck.py, so let's go ahead and install that. And since I'm using IPython, I can use this special exclamation point syntax to use my command line as I would if I hit exit, but without exiting from the terminal. All right, so now let's see what happens if I run this code now that I have the library installed. There we go, and it works the exact same way as the others did, but now all the stuff that I needed to do behind the scenes is even further behind the scenes. So you can kind of think of it like a movie. So to create a movie, to create a TV show, yes, you have actors, yes, you have sets, yes, you have costumes, but you also need cameras, you also need sound, you also need a director. So an enjoyable movie where, like, let's think of like a movie like Barry Lyndon by, I forget the director's name, but Barry Lyndon is a movie I like, and it's really immersive. It immerses you like back in kind of older like historical times, like and now if that movie we're showing you the director, we're showing you the camera, we're showing you the sound equipment, it just wouldn't work as well as if all that was off and you didn't see that and you only saw the costumes, the actors, the sets. That's what makes a movie enjoyable. So the same way, code, what makes it readable, what makes it usable, is narrowing it down and only seeing the relevant aspects of it. And the more you can do that, the more useful your code will be. Yeah, so the easier it will be to read your code. Now, I find there is a little bit of a trade-off with that, because if it's hard to find, like, because I find sometimes you need to open the hood of your car. So, you know, if you open the hood of your car and you get a message saying, oh, well, the engine is actually in the back, you go to the back, oh, the engine is actually underneath. Go underneath, oh, the engine is actually on the ceiling. You know, it gets hard quick. So I think there definitely is a little bit of a caveat with this kind of abstraction now, because if you want to see what's happening behind the scenes, it can be a lot more difficult if everything is really abstracted out. Then here you know exactly, oh, okay, I know exactly what's happening. Here's the site we're going to. Here where, you know, but here you can't even see the URL, so you don't even know what site you're logging into. You know, you're using a DuckDuckGo PY article, but you don't even know see these two examples, you see the full URL of where you're going to, and you can copy it and you can actually go to that URL and see what's there. But here, that's abstracted away, and that's considered a part of the set, that's considered a camera, that's considered a audio equipment, so you only see the actors, the costumes, and the set. So this is not considered a part of the set here, but but let's say you're a director and you're trying to watch your movie, you know, they have that thing that says action, and it shows you information about what this scene is meant to be. Sometimes you really need to see that information, so just including it in the actual footage is helpful. I hope they speak about that some more. I'm not sure if they will. Let's go down to layering, and then that will be the end of this video. I've got to move on to something else. Encapsulating behavior by using abstractions is a powerful tool for making code more expressive, more testable, and easier to maintain. Note, in the literature of the object-oriented OO world, one of the classic characterizations of this approach is called responsibility-driven design. It uses the words roles and responsibilities rather than tasks. The main point is to think about code in terms of behavior rather than in terms of data or algorithms. Abstractions and ABCs. In a traditional object-oriented language like Java or C#, you might use an abstract base class, ABC, or an interface to define an abstraction. In Python, you can, and we sometimes do, use ABCs, but you can also happily rely on duck typing. So ABCs are abstract base class. I'm not sure what duck typing is, though. They haven't explained that. The abstraction can just mean the public API of the thing you're using, a function name plus some arguments, for example. Most of the patterns in this book involve choosing an abstraction, so you'll see plenty of examples in each chapter. In addition, Chapter 3, Abstractions, specifically discusses some general heuristics for choosing abstractions. Okay, so we're going to highlight this part here. It looks like I can automatically highlight that. So now we gotta change the bookmark. Okay, and we'll click apply. See if it works here. there we go. So, yep, that's going to be it. I've got to move on. So, I will see you in the next video.